Okay, can you hear me, guys? I hope yes. Okay, I will switch to the presentation. If you cannot hear me or if there is something wrong, just please let me know and I will try to fix it. Thanks to Enzo for this nice presentation and all the effort that they are doing with this group. I think it's pretty cool. And I will start the talk now. Hi, all of you. Welcome to this talk about Ktor and some proposal of architecture. I hope you are all doing fine with all this pandemic going on all around the world. Difficult times, but let's try to make this talk interesting. So let's start and let me first introduce myself. You might not know me very well. My name is Jorge Rego. I'm currently a senior Android developer at Posse.com, and I'm also responsible or the developer of Ktor Easy repository at GitHub. It got 32 stars in the GitHub. It's such a not expected success for me. I think I got really positive feedback about that. So I said, well, let's prepare a talk and let's share this with the rest of the world and get more feedback. So all the examples that you are going to see in this talk are available in my GitHub account. You can see it in there. And also Ktor Easy is available in my account. Also, I'm writing some articles about Ktor and this architecture and testing at medium.com. You can check my profile there if you want. And I think they are really interesting articles to achieve a deployment of a Ktor server and also monitoring and other things. So if you are interested, you can check it there. Okay, so let me introduce the index the topics that we are going to discuss during this talk. First of all, I want to go through some architecture introduction and overview, where I will briefly talk about this architecture proposal and some of the key aspects of it. Then I will move to talk about about the layers and responsibilities of each layer. So you can see the layers there. We will see them in a diagram in the next slides. Then I want to talk about dependency injection, because I think it's a key concept that we want to talk. In case you didn't hear about yet, I think it's something that we need to discuss. And then I will end the talk talking about how to properly test this architecture, because I think testing is an important part of developing our servers. Okay, so let's start with the architecture introduction. Let me start with saying what this architecture and talk is not and what this architecture is. So I will start with what this architecture talk is not. This is not a standard way to build servers with Ktor. I'm not trying to convince anyone to just follow this approach. There are more ways of developing Ktor servers using other platforms and technologies. So pick the one that fulfills all your needs. This is just one approach. So try to find the good points and the bad points, and then choose wisely. I'm not a senior backend developer. I'm an Android developer. I know something about backend, but I'm not an expert. So don't expect maybe the best naming references or standard ways of dealing with things, because I'm not a senior backend developer. So please forgive me for that. This will be a top performance server. It's a Java program. At the time that I was creating this and using Ktor, there was just the Java version of the server. So this will run in the JVM, and we know that it's not the fastest in the world, at least not that fast as Node.js, Go, or others around. But yeah, nobody wants to code in JavaScript, right? So this is another option, let's say. And I won't show how to handle small things in this talk. I think the documentation and community around Ktor are really nice, and also Kotlin. So if you find yourself stuck, you can always ask the community. They are really nice people, and they will solve your doubts for sure. Okay, now let's move to what this architecture is. I think it's a clean approach to build servers with Ktor. It can be better, but help me to build it in a better way. I think it's useful reference. It's a useful reference for Android and Kotlin devs to implement backend solutions. Yeah, I found myself trying to develop my backend in Node.js, and after a couple of weeks, I found myself trying to killing myself after reading the code. So yeah, I think this is a nice approach to start writing backend solutions. It's another option. Also, I did this to try to demonstrate a bit that Kotlin backends works nicely in a production environment. Currently, my service is running multiple instances of Ktor, and I had no problems at all. The only problems were related with my own bugs. So I think it is saying quite a lot about the technology. And I think it's an option if you want to have a maintainable, testable system. We all know what happens when the system grows, and I think it's better to be prepared to maintain them. So if you get an architecture that is maintainable and testable, I think that will make your life pretty easy. Okay, so what are we aiming for with this architecture? Basically, split responsibility in layers. Each layer should be responsible of achieving something within the scope and nothing else. So dividing responsibilities will help us testing, developing, and aligning with the rest of the team. Also, we are aiming to inject dependencies. We will talk about dependency injection later to explain you a bit deeper what this is. But just to introduce this, if you want to make your code testable, each layer should get its dependencies injected. We want to connect by interfaces. In order to inject dependencies, those dependencies should implement an interface, and also it will help on testing and disconnecting the different layers. We also want to make it easy to adapt or change. So we all know that implementations can change over time, so better be prepared for that. So this should be a crucial thing to include in our architecture. And also an important point for me is that using our architecture, defining our architecture will allow us to have a well-known structure, and the team will speak the same language. So if you make this architecture clear for the entire team and you make it a convention, then all the team will follow, and it will help on recognizing the different layer responsibilities and how to structure your coding. And also, if you're working with a PR system, like GitHub, for example, then it will help on reading the code, understanding, and then getting the PRs merged faster, I think. Which libraries are we going to use? So basically Kotlin and Ktor, obviously. Gradle, you can also choose like Maven, but I prefer to use Gradle. I think it's easier for Android devs to switch and keep Gradle as the build system. Yeah, we are going to use as well Coin as our dependency injection tool. Yeah, we will see later that it's not a real dependency injection tool, but later we will discuss that later. Actually, we will use Coin Ktor extension, a specific extension for Ktor that integrates pretty well with Ktor. Also, we will use Exposet that is going to be used for connecting to the database. And in testing, we will use JUnit 5 and Mock-K, and maybe some assertion library that's not really important to mention here because just to make the assertions. Okay, so this is the architecture overview with the different layers that I've implemented. Let me go through the different layers and explain briefly what they are responsible for. Basically, the application Kotlin file will be responsible of starting the Java app, also recovering the config, initializing Coin, and starting the Ktor engine. The module Kotlin file is going to be responsible of Ktor feature and module installation. We will see later an example on what is happening inside. There are more things happening there, but just a brief explanation. Then we have the different modules. These modules are the root definition classes, are extension functions of routing, and I normally group them. One module will represent the different CVPs routes. So let's say that module A can be user module, and then all the routes based or used for users are going to be in this file. The next layer is the controller layer. So this is where all the business logic is going to be, and this has a relationship with the modules with one-to-one. So each module will have a controller to deal with the different routes that are being triggered. Our business logic will need some support from APIs. So controllers will have access to the different APIs to fetch data and store data. And the different APIs will have some data access objects to communicate with the database. So these are the different layers that are present in this architecture. Okay, let's go a bit deeply about the layers and the different responsibilities. So basically, the application layer or the application Kotlin file that we saw before, it will be responsible of starting the Ktor application, the engine, and the port. It will recover the Hokun config from the file. It will start going with all the dependencies that are required in the app, as you can see in the big square in the middle. We will call the main function that will trigger the function in the module layer. So basically, this small main function that you can see there will be calling the big module Kotlin file that you see there. And in this layer, there is not business logic at all. So don't place business logic here because we will place it in a different layer. Okay, so the next one is the module layer. As I mentioned before, it's going to be responsible of installing application features and interceptors, also the routes and status pages and other features that our server is going to use. As you can see here, no business logic again. This is not the place to put the business logic. This is going to be, the business logic is going to be placed in the controller. If you can see at the bottom, the routing is being defined here, but we are calling the different modules, the CVP modules that we are going to see after this slide. Something like a registration module, authentication user module inside the authenticated path. So yeah, let's move to the module CVP. So in this case, I had a screenshot of a registration module. This is one of the CVPs that I'm using to register users. So you can post users, you can authenticate, and you can generate tokens. The responsibilities of this layer is, of course, defining the routes, as it is a function extension function. For routing, you can use the different methods to define the routes. So you can use post, delete, get, update, or put. And you can. Another responsibility of this layer is receive the different parameters that are being recovered from the root. And then when you have the parameters, you delegate everything to the controller where the business logic is, and then you get back the successful response. As Ktor is working, in case of something is going wrong, you can throw an exception, and then this exception is going to be handled by status pages. no business logic here again, because yeah, we will see business logic in the next layer, that is the controller layer. Okay, controller layer. This is one of the biggest layers, of course. This is handling all the business logic. This handles transaction start end with the data DV query block that you can see in the middle square. You can also map models from your model objects to the response objects in case you don't want to send all the information that is defined in your model objects, such as passwords or other stuff. And this should implement an interface. As you can see at the top right, registration controller is our interface. And you might be thinking, transaction database logic at business logic layer. Yeah, it's a bit weird. I've been thinking about this, but after thinking it for a while, Ktor way of working with throwing exception, being catched by status pages. So handling transaction at this level seems convenient, because if you want to roll back some operations, or if you want to control which operations to roll back and which one should stay, then I think this is going to be defined by your business logic. So I think it makes sense to drop this transaction control here. There might be better ways of dealing with this, of course, but I didn't have the time to figure how to improve this. If you have suggestions, please let me know. And you can also fire a PR in my GitHub repository. All PRs are welcome, and I will discuss with you if you consider it is important to include them. Okay, let's move to the next layer. So API layer, responsibilities, fetching and storing data from and to one or many sources. Yeah, just using data sources to or data access objects to fetch and store data. It can also happen object mapping. So if you have a data access object that is returning object entities, different model from the data access object layer, you can map it to your model layers or model objects. This layer should throw its own exceptions, because if you want to disconnect the different layers, you need to create your own exceptions in this layer, and should also implement an interface. So as you can see at the top, user API is the interface that we are using here. Okay, so data access object. The responsibilities of this layer is, as we are using exposet, it's defined in the table as well, not only providing the methods to fetch and store data. In this layer, in those methods, we need to map databases, database rows into entities. So the model that we are returning from the data access object should be converted from the rows that we are recovering from exposet. And it also needs to implement an interface. As you can see at the top, user data access object, or user DAO, is our interface. Okay, so yeah, we are in the dependency injection part. So what is dependency injection? It's a complicated term or idea. So basically, it's a design pattern where an object receives other objects that it depends on. And which dependencies implementations to be received are defined outside the object using them. As we saw in the previous part in this application layer, the initialization is defining which implementations are going to be provided to when an interface is required. So in this case, if we want to recover a database provider contract, as you can see in the line 13, then we will provide a database provider object. So this is what means external provider for dependencies. Okay, and which advantages of using dependency injection are we going to get? Basically, layer isolation. So if you provide the dependencies from the outside, you can provide whatever implementation you want. So while testing, you can use those for mocking as well. It will improves reusability. So if you have a dependency already available, you don't need to implement it again, and it will change your mind a bit to always think if that dependency is already provided. So it will improve reusability. And it will also reduce boilerplate code, because some of the object instantiations are going to be painful in some cases with a lot of fields to fulfill. So if you have that already in place with the dependency injection tool, then you just need to call inject, and then you get that object instantiation with all the fields. So it is going to reduce a lot of boilerplate code. And I want to end this part mentioning a tweet from Ken Beck. If you don't know Ken Beck, you need to Google it after the talk and check who is this guy. But basically, he's saying that dependency injection is a lovely example of Jevons paradox. Yeah, you might not know what the Jevons paradox is, but let me explain it to you. Basically, Jevons paradox occurs when technological progress increases the efficiency with which a resource is used. And by reducing the amount necessary of that resource to any one use, the rate of consumption is increased. So the demand of the resource is also increased. So basically, dependency injection increases code reusability, reduces the number of needed tests, and makes them easier to be done. And this makes testing easier to be adopted, and so to create more tests. So this is helping on defining or happening the Jevons paradox also with testing by applying dependency injection in our architecture. And something that I mentioned before, we are using Coin. There is a difference between dependency injection versus service locator. Coin is not a real dependency injection framework, but a service locator. There is a tweet from Jake Wharton here in the link that you can check, where he's explaining the differences. But basically, service locator is not really checking that the dependencies are being fulfilled in compilation time, but dependency injection tools are doing. And also there is an overhead of using service locator because it is a bit slower in theory. So yeah, in some technologies like entry, this is going to be important, but in Ktor, as the overhead is being placed when the server starts, this is not going to impact us that much. As I mentioned there, we are using here Coin Ktor extension that is working really good with Ktor already. I think it's pretty useful for us, and the drawbacks of using it are not that much. So I think it's a good tool, even though it's not a real dependency injection tool. Okay, so let's see how the dependency injection is happening in the architecture. Basically, we are starting injecting from the module CVPs onwards. So module A, or user module, or whatever we call it, is getting the dependency injected. So controller instance is going to be injected in module. The same is happening for the controller, getting the APIs injected in the controller, those dependencies that controller needs. And the same is happening with APIs with the data access objects. In case of database, data access objects have a dependency with the database, but Exposet is managing this dependency by instead of allowing us to do it. So it's easier. And all objects that are injected have to implement an interface. This is crucial for later on disconnect the different layers. And that is basically the structure that we get after integrating the dependency injection in our architecture. Okay, and now we are reaching our lovely testing part. I hope you enjoy this part because I think it's quite important. Okay, before starting, let me give you some advices about testing. You might know this already, but I think it's good to share with everyone. So let's start. So think before start coding your tests. So to be successful at testing, you really need to know what do you want to test. This is crucial. So design your test cases properly, understanding which layer you want to test, which dependencies you need to mock, and which values you need to provide to simulate the scenario that you want to test. And if you do this, you are going to get really nice tests. So remember, think before start coding your tests. Don't try to achieve 100% of coverage. Yeah, that's the dream. But if you can always achieve 100% of coverage, you are dreaming and you need to wake up. It's not the real world. If you are in a company and you are working in real life projects, you have deadlines, you have CVP's deliveries, you have some schedule. You most likely are not going to be able to fulfill 100% of coverage. My advice, define a proper testing plan, prioritizing those layers that have crucial logic. I think this is the most important. So just prioritize what is the most important to be tested. Define your instrumentation. What do I mean by instrumentation? I mean test data objects, abstract classes, extension functions, whatever it is going to be useful for you when creating your tests. So better be prepared for the long run. Don't just place everything in your tests and leave it there, because at a certain point, that is going to make it harder to read, to change, and to maintain. Maybe the first week is going to be painful, but after that, I think you won't regret to spend time doing your instrumentation for testing. Yeah, remember the Jevons paradox that we mentioned before. If you make it easier, it is going to be easier to be adopted by the team, and then that will increase the number of tests, and then you will get a higher quality product. And I think this is key when you try to deliver a high quality product. Not all layers should be tested with the same tools. Some tools, like, for example, the test application engine that Ktor is providing, can be restricted to be used only in external layers. So you don't need to always make use of this and always use a test application engine to test all your layers. You can restrict that to the most external layer in your module, CVP modules layer, and then the rest of the layers can be just unit tested without the need of using that tool. Even when it is a nice tool from Ktor, you can make your life easier just getting rid of that in the rest of your layers. Using a good architecture will help you to test properly. If each layer has its responsibilities, its dependencies are injected, and you properly abstract them, you will be able to properly unit test each layer. And if you can unit test each layer independently, that will help on asserting that the layer is working properly. Of course, later you need to do some integration tests and some other type of tests, but yeah, this will always help on isolating, and this is key. This is key when you want to test your different layers. And test cases must serve a purpose. Writing tests is kind of cool right now, but you have to run them. How can they bring more value? You need to, for example, integrate them in your continuous integration pipelines. You can also get peer approval checks with integrating your tests. Or maybe after each branch push, you can run your test to verify that everything is fine and nothing is broken. You can choose many options, but please run your tests. If you write them and you leave them alone, they are not bringing value. And this is one of the key things of creating your tests. And these are some of the advices that I wanted to share with you related with testing. And reaching this point, you might be thinking, why am I telling you so many things about testing in an architecture talk? Yeah, correct. Some of the possible answers to this question can be A, I want you to suffer. B, I was a QA engineer before, so I need to show off. Could be. Or C, testing should be part of your responsibilities, so better prepare your architecture for that. Yeah, obviously is the option C. When designing your architecture, you need to consider testing if you want to deliver a high quality product. You should not change your code, such as visibility modifiers and other stuff, to make it testable. But you can always adapt your architecture a bit to making testing easier for your team. And this is what is important when talking about testing and architecture. Okay, so now before moving to some layer testing examples, let's recap a bit about the architecture. So this is the last diagram or the last architecture example that we saw with the different layers and the injection happening between the layers. So I'm going to start from left to right, starting in the modules layer, and then I'm going to move onwards until data access objects. We are going to test our business logic, abstracting it from app initialization. That is why I'm starting from the module onwards. If we want to test application module layers, we can use other tools such as API testing tools like Rest Assured or using the test engine from Ktor. But we need to see how to disconnect and how to work with these layers in a different perspective and maybe using other tools. So let's start with the root testing. So the module A, module V layer. So to test this layer, I'm using the test application that the test application engine that Ktor is allowing us to use for testing. It is encapsulated in with-based test application. That is a function that is part of my instrumentation. It is also in the test, you also need to install your roots in the test application engine. This is happening as well in the instrumentation. It is not in the screenshot, but you can check all of this in the repository in GitHub. If you are curious and you want to know more about all the instrumentation, it is already there and you can check. After that, we are mocking our dependencies, such as registration controller. We are defining what should happen to recreate the scenario that we choose to test in this case. So return the response user. We are triggering the root by defining the call and the path that we are calling here with the parameters or headers and the body. And then we are asserting what is the expected result from the response in the call or from the other different values that are inside the call that we are recovering. And this is how we can test our root layer or module layer. If we move to the controller testing, we have our tests. And in this case, the controller is going to be our sister under test. So the real object that we are going to call the methods, and then we are testing the code that is inside the controller methods. So basically, we are again mocking our dependencies, line 49, 50, where we mock API calls with expected return to recreate the scenarios. Then we use the run blocking for coroutines, and we call the real method for the controller to create the user. Then parameters are recreated as they are passed from the module layer or the root layer, and then we assert over the return we get from the controller. Assertions can also happen against the mocks to check that they are being fired or that they are being called number of times, and also you can check that there is that the method is throwing an exception, not recreated in this example, but I think there are other examples in the repository to check if the method is throwing an exception. And this is how we can test our controller layer. API. This is a really easy layer to test. Again, mocking our dependencies that are the data access objects. Then we call the API object, a real method, passing the parameter, and then we are asserting over the response that the API is returning to us. We can also assert over the mocks, and we can also assert if the method is throwing something. Really easy to test. And finally, we are reaching the data access object testing layer testing. In this case, we are testing our data access object. Then we need a database in memory. That is part of the instrumentation. It is not reflected in this screenshot, but you can check the repository to see how this is working. And we are starting a transaction block because we are doing real transactions over in-memory database. We create the schema. Normally, when you are testing your systems, you need to recreate the environment. So you create the database, and then you need to create the different tables that you're going to use in your tests. So this is what create the schema is doing. It puts all the user table inside the database, and in case you need to inject some fixtures, you also can do it in there. And once that we create the schema, we call the method that we want to test, and we do our assertions over database state. So we are using getUserById to check the database state. And then we assert that the user that is being returned is the one that we inserted. One note to say here, basically, create a schema is being integrated inside this transaction block. As you can think, this create a schema can go to the setup method in JUnit. I tried to include this in that method, but I don't know why it was not working. So I had to integrate and create a schema inside the transaction block inside each test. It's not proper, but I didn't have the time to go deeper and investigate a bit further. If you find a way to make it work or a different way to make this create a schema, then please let me know or fire up PR in the repository. I will be really happy to see how this can be done. And yeah, I think this is all related with the presentation. And yeah, thanks for watching. If you have some questions, please don't be shy.
Let me share the Slido. Just give me a second.
Yeah.
Yeah, we have just one question. Can you see it? Okay, perfect.
Yeah, I can see it. Can we split the different business logic? I mean, it roots into their own modules coming from the multi-module Android side. Business logic roots into their own modules. I don't really get the point. Maybe if the one making the question can explain a bit more.
In the meantime, there's another question in the chat. So what if you annotate the setup function with JUnit method before each, then create the schema before every test probably?
Yeah, that is what I was.
Yeah.
That is what I was talking about. I try to do it in that way, like preparing. You always need to prepare your tests grouping all the setup functions like create a schema in your before each. I tried to do it, but as it was out of the transaction, even I tried to create a new transaction after the database in memory was created, but it was not working. When I was running the tests, it was saying that the table was not there. So in order to make it happen, I had to move the create the schema inside the transaction, inside the test. Didn't have the time to go deeper. As I said, if you want to investigate, I'm really happy. And if you find a way, please fire a PR. I'm going to be really, really happy to see a PR in the repository.
New question.
Yeah. Can you have multiple Gradle modules in Ktor? Yeah, I think you can. I think it's like a regular Gradle project. You can have multiple modules. I'm not sure how they fit each other or how to include them, but I think you can have a module for common logic, and then you can have multiple projects or multiple servers. I think so.
Perfect. If there are no more questions, I'll say thank you so much to Jorge. And yeah, very interesting talk. Thanks so much.
Thanks.